Science and engineering are closely related. In order to solve problems, engineers have to apply scientific principles. Physics is especially helpful for engineers. Look at this dome. This is the dome on the over the lobby of San Jose City Hall. It's built almost entirely of glass. Now that presents some problems. It gives this great view and it provides a lot of natural light inside the building, but glass is not a traditional building material, especially glass that is thin enough to be transparent and be used as windows. So what did the engineers have to do to create this dome that gives this amazing view and lets in a tremendous amount of natural light and provides a lot of open space without allowing the elements to come into the building? It's still waterproof. And think about what the designers had to think about what they had to think about, and what compromises they might have had to have made. In other words, what trade-offs were there? If they wanted to build, I'm sure they would have been happy to have built something entirely of glass. But what is the purpose of all of these metal structures that are dividing up the glass? Why are they necessary, and why are they in that design? And what are all the things that engineers and designers have to think about when producing their products? Engineering has a different focus than science. Scientists try to explain phenomena. They perform experiments and they try to explain how the natural world works. Engineers, on the other hand, identify problems, define those problems, and then try to solve them. In order to solve those problems, engineers have to apply scientific principles, but they are less trying to explain why things happen the way they happen, and more trying to take advantage of what scientists have learned to create products and solve various problems. Let's look at how science and engineering are similar and different. What does a scientist do and what does an engineer do? A scientist attempts to explain phenomena. They observe something that's happening in the world, and they try to explain why or how it happens. In order to construct those explanations, they often do experiments. The scientists develop theories. Theories are ideas about why phenomena occur or how phenomena occur. They are rigorously tested, and when all of the evidence supports an idea, that's when it becomes an accepted scientific theory. Scientists also test their explanations. That's what an experiment is. They come up with an explanation, excuse me, and then they test it. They test it rigorously, and they open themselves up to having every other scientist in the world test their theories and explanations. Engineers, on the other hand, they take the work that scientists have done and they look at the world, and they see problems. They see things that they would like to try to solve, and they define those problems. After they define the problems, they come up with solutions to the problems, and they test their solutions. When they test their solutions, they then try to improve their designs. A design is a solution to a problem. So scientists define problems, and then they develop solutions. They design solutions. They test those solutions, and then they improve their designs. Engineering is what is called an iterative process. That means you go through it over and over and over until you get a solution that is acceptable to you or to the people you were solving the problem for. Both scientists and engineers use models. Scientific models we'll learn more about. Scientific models are things that attempt to explain phenomena or predict what might happen based on a phenomenon. Scientific models are explanations or predictions. Engineering models, one type of engineering model is a prototype, where engineers may develop a model, a small scale or a semi-functioning version of something before they come up with their final solution. Now, basketball is rarely played on concrete, right? We know concrete is strong. It's used for sidewalks, it's used for buildings, but basketball is often played, if it's inside, it's often played on a wooden floor or asphalt. Why? Why? If concrete is so strong, why don't we play basketball on concrete? And the answer has to do with the definition of the word strong or strength. Yes, concrete is strong in certain ways, but sometimes strength is not just resilience, but it's flexibility. Certain products that are used to build buildings or cars are designed actually to be flexible, not to be super rigid. Wood is flexible. Asphalt is more flexible than concrete. And so these are better surfaces for basketball courts where people are going to be running around, bouncing balls, and it's still strong, but it's strong in a different way. So let's think about specific terms when we're describing criteria of our engineering solutions. A benefit is something that is, well, it's something that's beneficial. So it's an advantage or something positive about a solution. When you come up with a solution, you want to think about the benefits, risks, and costs. The benefit is something that's positive about that particular solution. A cost is something that it's not necessarily money, but it's some kind of a disadvantage. Um, so there are certain costs associated with any solution. A risk is a cost that might happen. So if you built a wooden basketball court outside, it probably would not survive the weather, especially in parts of the country where there's a lot of snow or rain. We analyze benefits, costs, and risks of each possible solution because we need to figure out what trade-offs have to be made to come up with the best solution for a specific situation. Often you have to accept some kind of a cost or a risk in order to gain a certain benefit. Think about all the products you own. These are all things that are designed, often involving engineers. Think about your cell phone. Well, what kind of trade-offs have they made to produce that specific phone? Trade-offs that have to do with size, cost, um, any other factors where there is a benefit, but that benefit comes at a certain cost or a certain risk.